All right, let's look at distance axioms. All right, let's look at the first one. All right, D1, it says that for all points A and B in space S, there exists a unique real number called AB. So AB is basically a distance. So this basically tells you about the existence and also since this means unique, so uniqueness of the distance. Right, so that's D1. So we know that the distance exists between any 2 points, and it has to be a unique number. Right, D2 says that for all AB, we know that the distance has to be non-negative. Right, so we don't want the distance to be negative, and distance is 0 if and only if those 2 points are identical. Right. So sometimes this is called positive definiteness. Positive definite. Right, so that's D2. It makes sense, right? So we don't want distance to be negative. And only when you have a 0 distance is that when you have 2 points that are identical. All right, D3. It says that for all AB, distance AB is equal to distance BA. This makes sense, right? Because if you measure distance from A to B and you measure distance from B to A, we don't want those measurements to be different. So it has to be symmetric. So this is symmetric. I would just say symmetry. How about that? All right. So those are D1 through D3. Makes sense, right? So that we know what the distance, somewhat what the distance should be, and that it has those characteristics. All right, D4 is kind of interesting. So this is called sometimes the ruler postulate or ruler axiom. All right. It basically, whenever you have a line, you can put tick marks so that we can pretend that it's going to be a real number line. All right, so let's go through each part. Part number 1, it says this. So we may set up a coordinate on L. So you have a line, say you have a line L. So, all right. Then we can basically map the line to a real number line. So we're basically talking about the real number line. So I'm going to say R. Then we have mapping from the line to this real number, set of all real numbers. All right. And it says this. We may set up a coordinates on L such that for all x on the line, so x is a point. So we have a point on the line x. Right? Then we have a unique number x, which is called a coordinate. So there's a coordinate x, right? And the notation is you use the square bracket to indicate its corresponding coordinate. So capital X, which is a point, and it has a coordinate, the lowercase x, right? So every single point has a corresponding coordinate. So that's what part 1 says, right? How about part 2? It says that for all coordinate x, so any real number x, you have a corresponding exactly 1 point whose coordinate is that number, right? So basically what it's saying is that if you think of a mapping from the points on the line to a real number, number 1 said that it is going to be a function, right? Because every single point on this line, you're going to have a single a real number corresponding to it. All right, part 2 is basically saying that here for all real number, there's going to be a unique number point x on the line corresponding to it. So which means that so there exists, so for all real number, you have a corresponding x. So it basically is saying that this mapping is going to be onto right? Also, it says that it has to be a unique one, so this actually also tells you that it's also 1 to 1, right? And this tells you that it's a function. And it's also 1 to 1 and onto, which means that it's going to be a bijection. So this is so this mapping is going to be a bijection, right? So essentially, 1 and 2 tells you that there's a bijection between points on the line to the set of real numbers, right? And part 3, it says this: if you have 2 points A and B on the line L, then we can always give a coordinate, whichever the coordinate, A at 0, and then B any positive number you like. So you have 2 points on the line, say A, and you have another point B, and you get to choose where the 0 is. So we can always give A a 0 and B any positive number. So B has to be a positive number, right? So we get to choose where the 0 is, right? So that's part 3. And part 4, once you can set up the coordinates according to part 1 through part 3, then we know the distance. We can define distance from A to B or B to A, doesn't matter, is always the positive difference between, or non-negative difference, absolute value of the difference between the coordinates. So in this case, you have, so let's say A is going to have a coordinate A, and a B is going to have coordinate B. The distance AB is just the distance from here to there. Is going to be distance AB, which is just a non-negative absolute value of the difference between the coordinates. So once you know the coordinates, we can find the distance. Just find the difference and take the absolute value, right? So that's how we define distance, right? So these are the distance axiom from D1 through D4, right? That's it. I hope that this was clear.